Welcome to another deep dive. Today, we're going to be tackling Meta's infrastructure journey,
Oh, wow.
from their early data centers to this current vision they have for a global AI computing system.
Yeah, it's a fascinating story. They've
Yeah.
never stopped kind of evolving,
Mhm.
and it's all driven by this need for speed and efficiency.
So we've got some great sources to kind of guide us today. We're going to be looking at excerpts from a technical article by Chunkang Tang, who is a research scientist and senior director at Meta,
Okay.
and it's called Meta's Infrastructure Evolution, from data center to global AI computing. And we're also going to be drawing insights from a feature article also by Chunkang Tang, and it's in the February 2025 issue of Communications of the ACM.
Right.
And that one is titled Meta's Hyperscale Infrastructure, Overview and Insights.
It's interesting because Meta's journey really mirrors the evolution of computing as a whole,
Okay.
going all the way back to mainframes in the 1960s.
Mainframes, really? I thought those were like in a museum somewhere.
Well, it's funny because a lot of the core concepts from back then, like virtual memory, actually laid the groundwork for the complex systems that Meta uses today.
Wow. So these seemingly outdated technologies still have an impact on modern innovations.
Absolutely.
And speaking of innovation, Meta's approach isn't just about bigger and faster hardware.
Right.
It's a fundamental shift from thinking of a single data center as a computer to envisioning their entire global network of data centers as this one giant interconnected system.
It's mind-boggling.
It really is.
And you know what the driving force behind all of this is?
What's that?
The insane demands of artificial intelligence.
Right.
AI workloads are a massive part of what Meta does, and it's only going to grow in the coming years.
So let's take a quick trip through time to kind of see how this all unfolded.
Yep.
Back in 2013, they introduced TAO, which is this huge distributed database that basically powers the heart of Facebook. It stores all the connections and interactions between users.
Right. And then in 2014, they implemented the data center fabric, which is this high-speed network designed to seamlessly connect servers within their data centers.
Okay.
This was a crucial step towards achieving, greater efficiency and handling the ever-growing volume of data.
Makes sense. Then in 2019, the whole data center as a computer concept really took hold.
Yeah.
And this paved the way for even greater optimization and really set the stage for their global vision.
So instead of treating each server as a separate entity,
Right.
they began to see the whole data center as a single unified computing resource.
Got it.
This allowed them to pool resources, optimize workloads, and achieve a level of efficiency that wouldn't be possible with a more fragmented approach.
So they were breaking down the walls between individual servers to create this unified and powerful environment.
Exactly. And this approach was super clearly demonstrated in 2023 with the launch of the Threads app.
Right. That was a phenomenal
A
success.
small team, just 5 months of development.
And boom, 100 million users in just a few days.
Exactly. And the fact that they could handle that influx of users so seamlessly is a testament to the scalability and robustness of their infrastructure.
It really shows their move fast philosophy in action.
Rapid iteration, continuous deployment, and a willingness to embrace change.
And it's not just about speed.
Right.
It's also about openness.
Internally, they foster a monorepo culture,
Okay.
which basically means that all their code lives in one giant repository.
Why?
This encourages collaboration and code reuse.
So it's like one massive digital library where anyone on the team can access, contribute to, and build upon existing code.
Exactly. Streamlines development and helps prevent redundancy.
Hmm.
And externally, Meta is a huge contributor to the open source world with projects like PyTorch, which is a machine learning framework, and the Open Compute project, which focuses on open hardware designs for data centers.
That's a pretty amazing commitment to sharing their knowledge with the wider tech community.
Oh, yeah.
Okay, so I want to understand how this incredible infrastructure actually works in practice. So let's say I'm scrolling through Facebook on my phone.
Okay.
What's happening behind the scenes to make that experience possible?
Well, it all starts with those strategically placed points of presence, or POPs.
Okay.
These are those smaller edge data centers that are scattered around the globe to minimize latency. So when you make a request,
Yeah.
it hits the POP closest to you.
So these POPs act like a first line of response, ensuring a quick experience for the user.
Right.
And then what happens next?
If it's a request for static content, like a picture or a video, it's probably served directly from the POP's cache or through their content delivery network, or CDN.
Okay.
This helps reduce load on the main data centers and ensures things load quickly.
That makes sense. But what if it's something more dynamic, like loading my news feed, which requires pulling personalized information from their database?
Then the request travels over Meta's private WAN, which is this high bandwidth network that connects all their data centers worldwide,
Oh, wow.
sort of like a digital nervous system.
And once it reaches the data center?
It hits the data center fabric, that super fast internal network we talked about,
Right.
and it zips between servers to gather all the necessary data for your news feed.
So all these different components are working together seamlessly to deliver a personalized experience to millions of users?
Pretty much.
That's remarkable.
What's even more impressive is how they manage all this processing while maintaining such a high level of efficiency.
Okay.
They've separated their processing into two distinct categories, online and offline.
Online and offline, what does that mean?
So online processing is all about handling user requests in real time,
Got it.
like loading a web page or sending a message. Offline processing involves things like data warehousing, machine learning training, and analytics tasks that don't require immediate responses.
So they can optimize each one independently?
Precisely. They actually use their data warehouse as a buffer.
Okay.
It's kind of like a decoupling point, allowing each type of processing to run smoothly without interfering with each other.
So we've covered how they handle user requests. But what about the developers who are building and maintaining these systems?
Yeah.
How does Meta keep their teams productive when dealing with infrastructure at this scale?
Well, that's a great question. And it leads us into the world of developer productivity at Meta,
Oh.
which we'll explore further in part 2 of our deep dive. Welcome back to our deep dive into Meta's infrastructure.
All right, so in part 1, we traced Meta's journey from those early data centers to their vision of this global AI-powered computing system.
Yeah.
We saw how they really value speed and openness and efficiency in their engineering culture.
And we followed the path of a user request,
Right.
marveling at the complexity and the elegance of their systems.
And we kind of touched on how obsessed they are with reducing hardware costs through these clever software solutions and their in-house hardware designs.
Right.
But before we get into those details, I'm really curious about something you mentioned earlier about their use of centralized controllers.
Yeah.
It seems like they're going against the grain,
Mhm.
especially when decentralization is so often touted as the key to scalability.
It's an interesting point.
Mm.
You're right, Meta's approach is definitely unconventional.
Yeah.
They've found that in a controlled data center environment, centralized controllers can actually outperform decentralized ones.
That's surprising. Isn't decentralization supposed to be more resilient, more scalable? Because it seems like if you distribute control, the system would be less vulnerable to failure.
That's what a lot of people think, and it definitely has its merits.
Yeah.
But Meta's experience suggests that centralized controllers, when they're implemented correctly,
Right.
can actually lead to better resource utilization and overall efficiency.
So it's kind of a trade-off between the theoretical benefits of decentralization and the practical advantages they've found with centralized control.
Precisely. And for Meta, the practical wins. They're engineers at heart, and they're always looking for solutions that deliver the best results,
Yeah.
even if it means challenging conventional wisdom.
Can you give me like a concrete example of where this centralized approach has proven successful?
Their private WAN is a great example.
Okay.
That's the network that connects all of their data centers.
Right.
Initially, they used a decentralized routing protocol,
Uh-huh.
but it wasn't as efficient as they'd hoped.
What were some of the challenges they faced with that, and how did a centralized controller address those?
Well, with decentralized routing, each router is kind of making decisions independently,
Right.
based on its own little local view of the network.
Got it.
This can lead to inefficiencies, especially when you have things like traffic surges or network outages.
Yeah, that makes sense.
The centralized controller has a global view of the network,
Okay.
so it can make smarter routing decisions,
Right.
optimize traffic flow, and proactively establish backup paths.
So by centralizing control, they gained a better understanding of the network as a whole and could respond more effectively to these changing conditions.
Exactly. And this resulted in both improved performance and increased reliability. It's a win-win.
And this shift towards centralization isn't limited to their WAN, right?
Right? Over time, they've actually migrated almost all their decentralized controllers to centralized ones.
That seems like a bold move considering the industry's love of decentralization, but I guess if it's working for them, why not?
Exactly. It's about what's most effective for their needs.
Right.
They've also found that centralized controllers are often simpler to implement and manage,
Okay.
which is crucial when you're operating at meta scale.
But they haven't completely abandoned the idea of decentralization, right?
Right. They're not dogmatic about it.
Yeah.
They realize There's no one-size-fits-all solution.
Yeah.
In many cases, they use a hybrid approach,
Okay.
combining a centralized control plane with a decentralized data plane.
Can you give me an example of that? I'm kind of having trouble picturing how that works.
Sure. Think about their service mesh service router.
Okay.
It handles billions of requests per second across millions of servers.
That's a mind-boggling amount of traffic.
Yeah, and that's where the hybrid approach comes in.
Okay.
It uses a centralized control plane to make routing decisions.
Oh.
But the actual data forwarding is done by a decentralized network of L7 routers.
So you have the centralized intelligence of the control plane
Yes.
combined with the distributed power and resilience of the data plane.
Yes. This hybrid approach allows them to achieve both efficiency and scalability.
Hmm.
And it's a great example of how they're always adapting and innovating to find the best solutions for their needs.
Sounds like they've mastered the art of designing for hyperscale,
Yeah.
always striking that balance between centralized control and decentralized execution.
Right.
It makes me wonder, though, with all this talk about efficiency and optimization, how do they keep their developers happy and productive?
Yeah.
I mean, working on these systems must be incredibly challenging.
Developer productivity is absolutely critical for a company like Meta.
Yeah.
It's something they've invested heavily in.
Right.
They've developed a whole ecosystem of tools and practices to help their developers build and deploy software quickly and efficiently.
I'm all ears.
Mm.
What are some of the key strategies they've implemented to boost developer productivity?
One of their core philosophies is continuous deployment.
Hi.
They're constantly pushing out updates and improvements.
Yeah.
Over 100,000 configuration changes are happening every single day.
That's incredible. How do they manage to make so many changes without introducing instability or breaking things?
Automation.
Okay.
They've invested heavily in automated testing and deployment pipelines,
Right.
which allows them to move fast without sacrificing quality. In fact, 97% of their services use automated code deployments.
So they've built a system where code can flow seamlessly from a developer's machine to production with minimal manual intervention.
Exactly. This frees up developers to focus on building and innovating.
And it's not just about automating deployment, right? They've also embraced the idea of serverless computing, which I understand has become like a dominant coding paradigm at Meta.
That's right. Serverless computing allows developers to focus solely on writing code without having to worry about managing servers or infrastructure. It's almost like magic. You just write your code, and the platform takes care of everything else.
That sounds amazing. It must be so liberating for developers to be freed from that.
It is. It allows them to be more agile and productive.
Mm-hmm.
And what's remarkable is that Meta was an early adopter of serverless functions.
Wow.
Even before the term FAIA became popular in the late 2000s, they were ahead of the curve as always.
They saw the potential of serverless computing long before it became mainstream.
Yeah, and their early adoption has given them a significant advantage. They had years to refine their serverless platform and optimize it for their needs.
It's clear that Meta has really thought about how to create an environment where developers can thrive.
Yeah.
They've streamlined the development process, automated deployments, and embraced serverless computing, all with the goal of empowering developers to build amazing products.
Right.
But all of this innovation and cutting-edge technology must come at a cost, right?
Yeah.
How does Meta manage to keep their hardware expenses in check?
That's a great question, and it leads us into another fascinating aspect of Meta's infrastructure. Their pursuit of reducing hardware costs.
Welcome back to the final part of our deep dive into Meta's infrastructure evolution.
It's been quite a journey.
It really has. We've talked about their humble beginnings, their global aspirations, all their software innovations, their embrace of centralized control.
Yeah, we even got into their vision for AI in the metaverse and the challenges of developer productivity.
Right, and we saw how they prioritize speed, openness, and efficiency in everything they do.
Absolutely.
But before we wrap things up, I really want to dive into Meta's in-house hardware design.
That's a key aspect of their success. It really sets them apart from other tech giants.
Yeah.
They design and build their own data centers, servers, network switches, even their own AI chips.
It's like vertical integration to the extreme. Why go through all that trouble? Wouldn't it be easier and cheaper to just buy everything from specialized vendors?
Well, it might seem that way, but there are compelling reasons for their approach. First, it gives them complete control over their hardware, so they can tailor it to their exact needs.
So they're not limited by what's commercially available. They can just optimize every aspect of their designs for performance and efficiency.
Exactly. And by designing their own hardware, they often achieve significant cost savings, especially at their scale.
I can see how that would be the case, but isn't hardware design incredibly complex and expensive? It seems like it would require a huge investment.
It does. But Meta has made that investment. They've built some of the best hardware engineering teams in the world.
Wow.
They have a deep understanding of their requirements and can create hardware that perfectly aligns with their software and their infrastructure goals.
So they've become their own hardware vendor.
That's a great way to put it. And it's not just about cost savings and performance. They're also super committed to open hardware design. They're major contributors to the Open Compute project, which promotes open hardware designs for data centers.
So they're sharing their innovations with the wider community to help advance the whole industry.
Exactly. They believe that open hardware can benefit everyone by driving down costs and fostering greater innovation.
I want to make sure we talk about sustainability too, because it's so important for companies with massive data centers like Meta.
Absolutely. Meta understands that they need to minimize their environmental impact,
Mm.
and they've made sustainability a core part of their infrastructure design philosophy.
What are some examples of how they're incorporating sustainability?
One key initiative is powering their data centers with renewable energy sources.
Okay.
They're not just building energy-efficient hardware, they're also using clean energy to run it.
It's a two-pronged approach. Reduce energy consumption and then use clean energy to power what you do consume.
Right, and they've set ambitious goals for transitioning to 100% renewable energy.
That's encouraging.
They're also committed to water conservation, waste reduction, and responsible sourcing of materials.
So it's about minimizing their footprint across the board.
Exactly.
Yeah.
From design and manufacturing all the way to operation and disposal.
It's great to see a tech giant like Meta taking this so seriously. It sets a good example for the rest of the industry.
I agree. They're proving that you can be both technologically advanced and environmentally responsible.
Okay, so as we wrap up this deep dive, I want to zoom out a bit and think about the impact of all of Meta's innovations.
Okay.
Their pursuit of efficiency and scalability and performance hasn't just benefited Meta,
Right.
it's had a ripple effect on the tech industry as a whole.
A lot of their innovations have inspired other companies and have become industry best practices.
Like what?
Their open hardware designs, their serverless computing platform, their approach to global resource management.
So they're not just raising the bar for themselves, they're pushing the whole industry forward.
Exactly. Their influence can be seen in how data centers are designed and in the adoption of serverless computing and in the focus on AI-powered infrastructure.
It's amazing to think that a company that started as a social networking site is now shaping the future of computing.
It really is. It's a testament to their engineers and their willingness to experiment and their commitment to pushing the boundaries of what's possible.
Well, this has been an incredible journey through Meta's infrastructure evolution. We've seen how they challenge assumptions, embrace new technologies, and build one of the most complex and efficient computing systems on the planet.
As they continue to innovate, it'll be exciting to see what they come up with next.
This concludes our deep dive into Meta's infrastructure. Thanks for joining us.
And be sure to check out the show notes for links to the articles.
Until next time, keep exploring, keep learning, and keep diving deep into the world of technology.